Hello students, in our previous class we have discussed about atomic mass and average atomic mass. Now in today's class we are going to discuss about the calculations of average atomic mass for isotopes. Okay, in our last class we have discussed about the atomic masses of isotopes. What are isotopes? So isotopes are having different masses. For example, carbon 12, carbon 13, carbon 14. If any element is given, for example, if carbon is given to you, carbon is an element. If it is given to you, this carbon has all the three isotopes, carbon 12, carbon 13 and carbon 14. It has all the three isotopes, understood? So the mass of the carbon element, okay, the mass of this carbon element depends upon mass of all these three isotopes. So here we are taking average of all the three isotopes as its atomic mass. Okay, how to calculate the average atomic mass? There is one formula I have already told you. Average atomic mass is equal to mass of isotope 1 into its percentage or relative abundance plus mass of isotope 2 into its percentage or relative abundance plus mass of isotope 3, so on, divided by 100. Okay, the first one, this is very important for 2 marks and even for your competitive exam also this is important. Here the percentage of chlorine isotopes are given along with their masses. Okay, chlorine 35 isotope is given and its natural abundance is 75.77% and its molar mass is 34.9689. Next, carbon 37 has 24.23% of relative abundance in that element and its molar mass is 36.9659. So what is the atomic mass of chlorine? Okay, chlorine 35 and chlorine 36, 37 are given. So what is the atomic mass of chlorine now? The formula is like this: mass of isotope 1, this one, into its percentage 75.77 plus mass of isotope 2, that is 36.9659, into its percentage divided by 100. Okay, here I have substituted 34.9689 mass of isotope 1 into 75.77, what is this? Natural abundance or percentage, one and the same, into 24.23, again percentage into mass, that is 36.965 and divided by 100. You simplify this, you will get the answer 35.452 unified mass, or we will take it as 35.5 unified mass. You know the atomic unit of atomic mass, unified mass or atomic mass unit, we write it as AMU. Okay, simply you take it as 35.5 unified mass. Remember, the atomic mass of chlorine is 35.5 unified mass. The second one, the second problem is, it's related to carbon isotope. Carbon 12, 13 and 14 isotopes are given along with their relative abundance. Okay, carbon 12 is the most abundant isotope of carbon. Okay, naturally available carbon has carbon 12 isotope. Understood? The percentage of carbon 13 and carbon 14 are very negligible. So carbon 14 is not considered most of the time. Here carbon 12 isotope has the percentage of 98.892 in the sample and its atomic mass is 12. A sample is given, a carbon sample is given. In that carbon sample you have what? 98.892 percentage of carbon 12 isotope and 1.10 percentage of carbon 13 isotope and 2 into 10 to the power of minus 10%. It's very small and it's negligible. Okay, carbon 14 isotope. Next, their masses are also given. I have written the formula. In your exam, you have to write the formula separately. So after writing the formula, you substitute these things in the equation. Okay, here I have written the formula. Here I have three isotopes. Mass of isotope 1 into its percentage plus mass of isotope 2 into its percentage plus mass of isotope 3 into its percentage divided by 100. Understood? The simple substitution. Now if you simplify, you will get the answer as 12.01 unified mass. Okay, while during the calculation, here you will get a small number here. In this part you will get a very small number. You neglect it. So you neglect this term and you consider only these two terms. Understood? This is very, very small. It's uncertain, completely it's uncertain. So no need to consider this term. You consider only these two terms, you will get the answer as 12.01 unified mass, or simply the atomic mass of carbon is taken as 12 unified mass. Next topic is about molecular masses. Okay, so what is molecular mass? So molecular mass is the sum of the atomic mass of all the atoms present in a molecule, or it is atomic masses of molecular masses is sum of the atomic masses of the elements present in the molecule. Okay, it's very simple to calculate. If you know the atomic mass of every atom present in a molecule, you can calculate the molecular mass. Okay, molecular mass represents mass of one molecule. Remember, molecular mass represents mass of one molecule. Atomic mass represents mass of one atom. Okay, you have to remember this difference, because there are one more term which is known as molar mass. Molar mass is different, molecular mass is different. They are completely different. Okay, molecular mass refers to mass of one molecule. Atomic mass refers to the mass of one atom. Here, one simple example is given. CH4, this is called as methane, a hydrocarbon. Its molecular formula is CH4. What is its molecular mass? So molecular mass is nothing but the sum of atomic masses of all the elements present in the molecule. Here we have two elements, carbon and hydrogen. There is one atom of carbon, its atomic mass is 12.01 unified mass, or you can simply take it as 12 only. You'll get the marks, no problem, you can take it as 12, plus there are 4 atoms of hydrogen, so 4 into 1. So now it is equal to 16 U unified mass, not gram, 16 unified mass. Okay, if you write 16.0434 also, that is 0443, this is also correct. 16 is also correct. No need to take 12.01, 1.008. Simply you can take 12 and 1. Nothing will happen, you will get the marks. Okay, next one, H2O molecule. So in H2O we have 2 atoms of hydrogen and 1 atom of oxygen. Here you'll get 2 into 1 plus 16 into 1, that is equal to 18 unified mass. So atomic mass of oxygen, you have to remember, that is 16. Atomic mass of hydrogen is 1. So there are 2 atoms of hydrogen, so you'll have 2 into 16.1, 2 into 1 plus 16 into 1, that is 18 unified mass. Understood? Similarly, one more example. So this is glucose. In glucose, there are 6 atoms of carbon. So its atomic mass is 12. 6 into 12 plus 12 hydrogen atoms. What is the atomic mass of hydrogen? 1. 12 into 1 plus 6 into 16. 6 into 16, that is 96. So you add this 72 plus 12 plus 96. That is equal to 180 unified mass. Next, molecular mass of NH3. NH3 is known as ammonia. So what is atomic mass, molecular mass of ammonia? You have to remember the atomic mass of nitrogen. Atomic mass of nitrogen is 14 unified mass. That of hydrogen you already know. So 14 into 1, because only one nitrogen is present. 14 into 1 plus 3 into 1, that is equal to 17 unified mass. Coming to benzene, its molecular formula is C6H6. So here atomic mass of carbon is 12 unified mass. There are 6 atoms of carbon. So 6 into 12 plus 6 into 1. Why? There are 6 atoms of hydrogen. So its molecular mass is 78 unified mass. Next, sucrose. C12H22O11. There are 12 atoms of carbon. So 12 into 12 plus 22 atoms of hydrogen. 12 into 1 plus 11 into 16. That is 342 unified mass. Okay. So this is about the calculation of molecular masses. This will be important for 2 marks. Okay. They will ask one question for 2 marks. Next concept is about mole concept and molar masses. So this is also very, very important. Here we need to define IUPAC term or SI unit, that is mole. What is mole? How do you define? Mole is nothing but 1 mole is the amount of substance that contains as many particles or entities as there are atoms in exactly 12 gram of carbon 12 isotope. So what is this? So this looks complicated. The definition looks complicated. Simply you can write like this: amount of substance that contains Avogadro number of particles, or amount of substance that contains 6.022 into 10 to the power of 23 particles. I'll explain this. 1 mole is nothing but it is the amount of substance that contains as many particles or entities as there are atoms in exactly 12 gram of carbon 12 isotope. ಇದೊಂದು term ನಿಮಗೆ define ಮಾಡಲಿಕ್ಕೆ, 1 dozen, okay, it means 12 items, okay, 12 items refers to 1 dozen. Here 1 mole refers to certain quantity or number. So what is that quantity? So that is 6.022 into 10 to the power of 23 entities, or simply I'll term it as particles. Now 12 gram of carbon 12 isotope has, remember, 12 gram of carbon 12 isotope has 6.022 into 10 to the power of 23 particles or atoms. Remember, 12 gram of carbon 12 isotope has 6.022 into 10 to the power of 23 particles or atoms. If any substance has this much of particles, then it is referred as 1 mole. For example, a substance is given to you. Okay, this substance has how many number of particles? This substance has exactly the same number of particles as there are particles in 12 gram of carbon 12 isotope. Understood? 12 gram, 12 gram carbon 12 isotope ಅಲ್ಲಿ ಎಷ್ಟು ಪಾರ್ಟಿಕಲ್ ಇರ್ತದೆ, ಅಷ್ಟೇ ಪಾರ್ಟಿಕಲ್ ನಿಮಗೆ ಕೊಟ್ಟಿರುವಂತಹ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಇದ್ರೆ, so that is termed as a mole. Okay, if this has 6.022 into 10 to the power of 23 particles, so then it is referred as 1 mole of particle or 1 mole of substance. Understood? 1 mole is the amount of substance, or mole is the amount of substance that contains as many particles or entities as there are atoms in exactly 12 gram of carbon 12 isotope. ನಿಮಗೆ ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೇನೆ. ಕಾರ್ಬನ್ 12 ಗ್ರಾಮ್ ಆಫ್ ಕಾರ್ಬನ್ 12 ಐಸೋಟೋಪ್ ಅಲ್ಲಿ ಎಷ್ಟು ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತದೆ, ಅಷ್ಟೇ ಪಾರ್ಟಿಕಲ್ 1 ಮೋಲ್ ಆಫ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಇರ್ತದೆ. ಓಕೆ, ಇದು ನಿಮಗೆ ಕಷ್ಟ ಆದ್ರೆ ಯು ಕ್ಯಾನ್ ರೈಟ್ ದಿಸ್ ಡೆಫಿನೇಷನ್: amount of substance that contains Avogadro number of particles, or amount of substance that contain 6.022 into 10 to the power of 23 particles. Next, one more term here I have written is molar masses. So what is this molar mass? This is the mass of 1 mole of substance in grams. So what is the difference between molar mass and molecular mass? See, molecular mass is written in terms of unified mass, U. Here, see, molecular mass of H2 is 18 unified mass. Molar mass of H2 is 18 gram. See, if I write 18U, this refers to a mass of 1 molecule of water. If I write the same quantity in grams, 18 gram, it refers to the mass of 1 mole of H2O molecule. So this is very important. Remember, if you write U as your unit, it refers to 1 molecule. If you write G as your unit, then it refers to 1 mole. That's the difference. Remember, don't confuse with these two terms. Molecular mass in gram is nothing but molar mass. Understood? Molecular mass in gram is nothing but molar mass. See here in the previous example, here I have written 342 unified mass. This is the mass of 1 molecule. If I write it as 342 gram, now what happens? This is the mass of 1 mole. Coming to this, 78 gram. This refers to mass of 1 mole. 78 unified mass refers to mass of 1 molecule. Understood? So here 78 gram of glucose has 6.022 into 10 to the power of 23 molecules of glucose. Understood? 78 gram of glucose has 6.022 into 10 to the power of 23 glucose molecules. But 78 unified mass of glucose, 78 gram of benzene has, not glucose, 78 gram of benzene has 6.022 into 10 to the power of 23 molecules of benzene. Okay, 78 unified mass of benzene has only 1 molecule of benzene. Understood? 78 unified mass means 1 molecule of benzene. 78 gram means 6.022 into 10 to the power of 23 molecules of benzene. Here also molecular mass of H2 is 18 unified mass. 18 unified mass refers to 1 molecule of water. 18 gram of What water refers to? 6.022 into 10 to the power of 23 molecules of water. Okay, this is about molecular mass, mole concept and molar masses. Okay, these concepts are very important. Thank you.